Welcome back to week 4, and in video 3 we are going to move forward and talk about the landforms in particular that are created by these rivers, braided, straight, and meandering. So the ones that we're going to touch on, what I'll do is I'll have a couple pictures to show you, and then we'll look at some areas in Google Earth. So some of these features include alluvial fans, deltas, entrenched meanders, floodplains, meanders, oxbows, oxbow lakes, stream terraces, and waterfalls. So the first that we're going to talk about, these two can often be confused by students, are alluvial fans and deltas. Now the difference between these two is that one of them empties into a body of water like the ocean, and the other empties into a dry valley. So one of them is in a desert environment, the other is in probably more of a wet environment. And they're both similar in that they're rivers that end in some kind of wide flat area, but the difference is one of those wide flat areas has water in it and the other does not. So here we've got Mississippi River Delta, that you can see here. Here's the river coming out, and then the delta is this whole entire huge thing. Currently active delta would be this tiny little part right here. And then here is this little kind of triangle shape is a side view of an alluvial fan. So if we go to Google Earth, let's look at that alluvial fan first. And we're going to go to Death Valley, take a look at some of the alluvial fans, and here you can see how that fan has this nice fan shape. That's why it has the name. So when we're looking at it on a map, it's going to have this fan shape, and then all the water is coming from this steep mountainous river that you can see up here. Pretty straight channel, pretty young. It's going to have a high discharge when it's raining a lot, which doesn't happen very often in the desert. So a lot of the sediment builds up in this river valley during the dry season. So in the wintertime, we still have freeze-thaw action that can happen. There might be a little bit of moisture on the rocks, but not quite enough to have water actually flowing. So we can have the rocks here breaking down that way. It can also break down by thermal expansion because the temperature change can be pretty dramatic in a day. And that channel collects sediment. And then when we have the wet season, rivers rush down these valleys, pick up that sediment, it empties into this wide flat valley here and immediately starts to slow down, deposit the sediment, and then as it's depositing the sediment, it's forcing that river to jump all over in different directions. So different seasons, you might have the river flowing out this way, over here, maybe to the north, or if it's dry enough in this valley, that water, as soon as it hits this area, will just start to filter down into the groundwater. So it might not even run out into this valley. It's pretty amazing. If we explore this valley some more, you can see some smaller fans over here. You guys can play around with this as well. So pretty interesting area. And here's one of those a big fan as well. So lots of alluvial fans, dry environment. And then we've got our deltas. So if you go to the Mississippi River Delta, we'll get a bigger shot of this. So here we've got the Mississippi River coming down, flowing past New Orleans, and then out here. So this is the active delta right now. And the reason why it kind of looks kind of funny, this is the rest of the delta that's built up over millions of years. But now the delta is building up here. And the reason for that is because we as humans have not allowed this river to jump ship and move and shift over time. Deltas and rivers at the mouth tend to, during flood events, they want to take the path of least resistance. They don't necessarily stay in that channel all the time. So this river at times will actually, and historically, millions of years ago, would jump ship way the heck up here and flow out this way. It actually wants to do that, to flow out the Atchafalaya River instead of following the Mississippi River. And you can see some of these windy patterns throughout this delta where it has flowed in different paths at different times. But now we don't want that river to move because it would be pretty expensive if this river jumped ship and left New Orleans high and dry. And we have lots of shipping routes that come through here, so it's pretty important to have that river where it is now. So that's why all the sediment is being basically forced out to this area to build up that delta. So that's delta. Let's take a look at the next one, meanders and oxbows. So here's a meandering river you can see in this picture. So what happens with meandering rivers, around one of these bends we have a couple different things happening. So we've got the outside of the bend, which we call the cut bank, and here's a nice picture showing you what that cut bank would look like. You can see it has a pretty steep cliff on it. It might only be a foot or two, it might be 3, 4, or 5 feet. It depends on the river that you're looking at. But this is where you have active erosion. So with these meandering rivers, the erosion is focused to the side. So the water coming around this bend wants to keep going in a straight line, but it hits the bank, can't keep going in a straight line, gets forced around the curve. So a lot of that erosion energy is focused on the outside of that bend. And on the inside of the bend is where we have deposition happening. So a lot of sediment gets deposited in here because this side is much slower flowing. So over time, if you have erosion on one side, deposition on the other, this whole channel moves over time. And here you can see over time how this river would change from stage 1 to stage 2 to stage 3. And if you look at focus in this area right here, these two cut banks slowly move closer and closer to each other to a point where they actually intersect and then cut off this river bend. And that's what we call an oxbow lake. Your textbook has a great description of that, so I would definitely check out those diagrams. So what do these oxbow lakes and meandering rivers look like? So we'll look again at the Mississippi River. It's a great example. We'll zoom in a little bit closer. So here's our meanders and then our oxbow lake. I got a nice one we can zoom in on, a couple very distinctive ones. Here's a nice example of an oxbow lake here. Here's another great example. A couple others down here. So the Mississippi River has a lot of these. And if we zoom in here, especially in this area, you can see in the landscape these kind of curved features. And what that's showing you is how this river actually migrated in this direction over time and then eventually was cut off. Which is pretty neat. And you can see that in a lot of different areas along this river as well. You can see some old meander scars over here as well. So that river is pretty active. It erodes and deposits pretty frequently and floods pretty frequently as well. So our next, moving on from meanders to entrenched meanders, basically what happens here is you have a meandering river that's developed, really old, and then something changes. So in this case, this is Bighorn Canyon in Montana and Wyoming. The Colorado River is a great example of this. What happens is something changes tectonically and the land surface starts to uplift. Now if that uplift happened really fast, the river erosion wouldn't have time to keep up with that uplift. So the river would just get diverted someplace else. But what happens in these entrenched meanders is the amount of river erosion down along the bed of that river is equal to the amount of uplift. So the gradation of that stream, the erosion, keeps up with the uplift. So as the ground surface is uplifted, the gradation is happening at the same rate. So that river can cut downwards instead of sideways as it would have. So we end up with these pretty neat entrenched meanders. So we'll take a look over here at the Grand Canyon, and here we've got some of these entrenched meanders. And if we want to take a side look here, let's see if we can get a side look at that valley. We zoom in, let's see here, let's turn us around, and here you can see, look at that entrenched meander, really steep cliffs. Here's that river coming around the bend, so pretty intense amount of erosion. So the uplift of the land was at the same rate as the erosion of the river. Pretty amazing. So the next thing are waterfalls. In waterfalls, we see these occurring in young river beds. or in a riverbed that has some kind of tectonic activity occurring to create a fault, to uplift one part of the landscape to create that severe drop in elevation. We can also change base level. So if we change sea level, then we're going to change how that river is going to erode or deposit. And we can also have what's called differential erosion. So if we have a top layer that's really resistant to erosion, bottom layer that's really easy to erode, it's going to be easy to erode under here, and then we'll undercut this cliff. Eventually this stuff falls down and this whole waterfall retreats upstream, which is pretty neat. The Niagara Falls in New York is a great example of a waterfall that is actively moving. So here's Niagara Falls. This is where the falls are currently. And this river is flowing, let me zoom out a little bit here, is flowing from Lake Erie over here, flowing this direction into Lake Ontario. And if I zoom in here, what we've got in this location right along here is what's called the Niagara Escarpment, and this is a sandstone layer. It's very resistant to erosion. This river has been slowly, this waterfall has been eating its way backwards towards its current point, and will eventually eat its way back towards Lake Erie, which is pretty amazing because we have this more resistant sandstone layer on top and then a weaker layer below it that's easy to erode, which is pretty neat. Those are waterfalls, and then we have floodplains. And floodplains, what we have here, is basically we have this wide flat area that this river, this meandering river, can migrate back and forth through, and so it can be pretty wide over time. And then stream terraces, these form when you have a river that it becomes stable, it erodes this wide floodplain. This blue line would be the first one, and then base level drops, sea level drops, and the river starts to erode lower. And we get the red area, and then base level drops again, and then it meanders only within this floodplain. So stream terraces tend to be a stair-step pattern on the edges of a river. So to see a floodplain, how big they can be, let's take a look at the Mississippi River again. And we can see this pretty nicely in the Mississippi River because a lot of farmland exists along the Mississippi River. So the floodplain for the Mississippi River can stretch from one side all the way across the screen. So pretty wide floodplain here. So this means this river could flood this entire valley if it really wanted to. Now you have various floodplains. Sometimes the river doesn't flood quite that much. It might only flood right next to the river valley. Sometimes it floods huge areas. And here if we keep scrolling up and up and up, we can see the floodplain changes over time. So that floodplain is going to be an area that during high discharge is going to fill with water. So those are major stream types, landforms that are created associated with each type, and we'll come back in the next video and talk about groundwater.